Okay, guys, I come back. So now we'll continue. So the next topic will be about functions. Okay, let's continue. So a function is a rule that maps each input value x to a single output value fx. For example, the rule square the input value and then add 3 would be written in function notation as this. Remember, always left side fx, right side, how to write it, like something like that. You can also write something like that. The only difference is first thing is like it means function, but second thing it means something about mapping. I mean, mapping and function actually they can express same thing. Their logic is same, and also transformation. These three things actually in math their logic is same, so you can always use mapping to replace function. Use transformation to replace function. Yeah, I mean I will explain it. Don't worry. Let's go back. So now here's some definition of a function can be 1-to-1 and many-to-1. What I mean? It means like 1-to-1. It means you put a value and you put an input value in function and you get the output value. I mean, if you put different input value, you always get different output value. So I mean, how to check this? How to check is this function a 1-to-1 function or many-to-1 function? Here's the easy way. Just you only need a ruler. If you just match this ruler, parallel with the x-axis, you just move it. If here is always only one intersection between your ruler and the graph of function, it means it's 1-to-1. So for this case, y equal x cubed is 1-to-1 function. But if, for example, this y equal x squared, if you use ruler from here to here, under you cannot get any intersection, but up you always can get two intersections except here's only one. But the thing is, if here's one moment that you have two intersection, then it is 1-to-1. As long as at some point in time the ruler parallel to the x-axis intersects the graph at 2 points, then this is a many-to-1 function. For example, yes, like y equal x squared is many-to-1, y to the x cubed is 1-to-1. So yes, remember here's a rule that can help you. So for example, this case, we can match. So one intersection, two intersection. So yeah, it's many-to-1. But guys, remember, the function only can be 1-to-1 and many-to-1. It means that function cannot be 1-to-many or many to many. So this, if you put ruler parallel with x-axis, it can check is if this function is one-to-one function or it is many-to-one function. But if you put your ruler like that, it's for checking is that graph express a function. For example, here's a circle. But the thing is, we use this rule to check 1 intersect, 2 intersect. It means that for one input value, it can be two output value match with this input value. So it means the circle graph is even not a function. So we don't have to discuss if the circle is one-to-one function or many-to-one function, because the condition of discussing if the graph is a many-to-one function or one-to-one function is this graph has to be a function. Okay, let me translate this logic. The premise of judging whether this function is a many-to-one or one-to-one function is that the graph must be the graph of a function. Yeah. So obviously circle is not a function of graph of function. So we don't have to discuss if circle graph is many-to-one function or one-to-one function. Yeah, it's the same. So remember, before you check is that a many-to-one or one-to-one, first you have to check is that a function. So 1 intersect, 2 intersect is not a function, so you don't have to discuss something later. But for this case, you see, it's always 1 intersect between ruler and graph, so at least it is a function. Then you can check 1 intersection, 2 intersections, so it's a many-to-one. So let's define what is domain and range. Domain is the domain of a function is the set of all allowed input values. So what I mean, it means, for example, this case. Let's remember it by the example. So find the domain of this function. Largest possible domain of this function. So it means if it's allowed input value, you just put it in this set. So it is domain. So because under the square root, it must be a positive number or 0. So it means 2 minus x must more than 0. Yes. Then we can solve this. Solve this inequality. So after you solve it, you will get x should be less or equal to. Okay, I don't know how to explain it. Let's find the example. For example, just imagine here's a function to identify if you are man or woman. The domain of this function, it must be all human, right? Because we this function is identify if you are man or woman, but so all allowed input values only can be human. I mean, if you are not human, you are not in the domain of this function, right? Does that make sense? So yes. Oh, okay. So for example, so here's three main things which you should consider when determining the largest possible domain of a function. First, you can never square root a negative number. So for this example, we use the first rule. And second, you can never divide it by 0. So for example, function y equal 1 over 1 minus x. So the domain of this function, how can we find it? We know that we can never divide it by 0. So it means 1 minus x cannot equal 0. So it means x not equal 1. So the domain of this function is x not equal 1. And also the third rule is you can never take a logarithm of a negative number or 0. If you make this mistake, you'll be thrown out of the window. Yes, probably you'll be thrown out of the window. Be careful. And guys, it's time to judge which two students make a mistake. So let's see. Here's a really similar example of something here. Because here is also something divided by something. So and we know that we can never divide it by 0. So we know that x minus 2 cannot be equal 0. So x cannot be 2. So the answer here, only solution 2 is correct. And I don't know what's happened here. Why he thinks it's negative 2. Maybe he just saw here's negative 2, so he is totally wrong. But this guys makes the rule. They mix the rule of these two things. So here's divide. So divided by, we only take care it cannot be 0. But only for square root, we have to take care. We can never square root a negative number, and for the log, it cannot be negative number or 0. Yes. So the range. So if we have a set of all allowed input value. So we also have a set for all possible outputs. All possible outputs, it means, you throw everything in this function, then you get the output. Because not everything can be output of a function. So for example, gender identify the result of gender identify function only can be man, woman, and many gender, maybe like 72 genders. But the output of gender identify function cannot be fridge, cannot be TV, cannot be computer, cannot be 1, 2, 3, 4, 5. So yes, we need a range of a function. We need a set of all possible outputs. Yes. I don't know, is this example really good, right? I respect to LGBTQ plus. Okay. I'm not some guys who. Okay. Let's continue. It's something about basic definition, 1 to 1, many to 1, and how to identify a set of function, and definition of domain and range. And let's talk about inverse function. Maybe everyone, I think you guys can get what does inverse mean, because before we said original operation and the inverse operation. You know that inverse operation and original operation can cancel out. Actually, for most of the time, inverse function can also cancel out with original function. And inverse function we write as f with -1 on top. And remember that it's not mean something like 1 over fx. Remember that it's something different. So for example, if f2 equal 4, it means f inverse function inverse f4 is equal to. So it's like no, it's not correct, Jesus. So it's like I have to find an example. Oh, let's make for example, girlfriend function girlfriend function. I mean, if we put oh my god, oh no, sorry, Jacobo, I make a mistake. If you put Jacobo in the function, the output will be Macy. If you put Ted in here, you get Lara. Oh my god, why I always make right mistake? And so the inverse function of girlfriend function, it will be boyfriend function. So if we put Macy in the function, we will get Jacopo. And if we put Lara in the function, we will get Ted. So boyfriend function is inverse function of girlfriend function. Okay, and actually these two functions should always work, except sometimes it's possible that somebody have many boyfriend or girlfriends, or they have many boyfriends and girlfriend is something really scary. So let's be. Yes, it's only happened in East Asia. Yeah, in East Asia it's always happened. So that's why here's always many movie about those topic. It's really funny. Yeah, it's really funny. So let's look this. I mean, here's the thing that only one-to-one function have inverse function. Because it is one-to-one, so it means if I put different input value, I will always get different output value. They are always different. Everything. If I put 1, I will get 2. So if I put 3, the output cannot be 2. No matter, only one's output is 2. So like that. But if many to 1, it's easy to understand. For example, just gender identify function. I put myself in the function. The output is man. I put my brother in the function. It's also a man. But if but gender identify function don't have inverse function, because if I put man in the inverse function of gender identify function, yes, the result can be, if I put man, the result will be all the men in the world. So it's not make sense. So only one-to-one function have inverse function, but many-to-one function don't have exactly serious inverse function. Yeah. Oh my god. Let me translate the word. I don't think it's correct. Only one-to-one function have strict inverse function. What strict inverse function mean? So it's because in the future, when you learn something about complex number, it's always, most of the time, the function is one to many. No, I mean most of the time you will face many to one, even many to many, because in complex number everything is changed, everything is so different. So strict inverse function is only for one to one function. Yes. I mean, if this part you don't understand it, I can explain it by I will typing something in the group chat. So no worries. So here's here's a rule to draw inverse function. The rule is if you have a original function, the graph of original function, then you just draw the line y equals x. Then you just reflect the function with, oh my god. Symmetrically transform the original function along y equal x. Then you can get the graph of inverse function. So something like that. So for example, sketch the inverse function of the following graph. You just draw y equal x and then symmetrically transform the graph, right, guys? And so it will be something like that. Haha, it's all the thing about function for the first part. Haha, we'll talk about it next time. So bye bye guys, and remember, do some question here. Let's see which question is better to practice. Yes, I mean for the first question is, if those question is easy because we just put number in here and calculate. It's just let's check if you are good at calculating. And yes, guys, do the 5a 5b 6a 6b 7a 7b, and just do this question to check if you understand how to use ruler to identify if it is a function or not, or if it is a one-to-one function or many-to-one function. Then here also here's some function write in like some like equation, and also judge if it is a function or not, which kind of function it is. So yes, just do some practice, and if you have question, just ask me. Or I mean, if you want to check answer first, then you ask me. You can throw all the question in the AI or just ask me. Yes, okay, you can ask me. Oh my god, yeah, you always can ask me. I always online. Yeah, so that's all, and something about sketching graphs, we'll learn about it tomorrow. Okay, so see you guys tomorrow.